everyone, this is Kevin with Noble IT. This video is going to be about multi-protocol BGP and MPLS. So yeah, this is my channel, and this is straight to the point, Noble, straight IT, and we're learning through it. Yeah, so as you can see here, this is our topology. We're going to start off with task 1, establish OSPF underlay with the MPLS core with loopbacks. I've already done that. I'm just going to show you the configs I have because at this point, you should be able to establish OSPF adjacencies between 4 routers, hopefully. And then we'll really start with task 2, establish connectivity with the customer edge routers to provider edge routers. So yeah, let's get started. This is considered the MPLS core right here. Provider edge 1 router, P1, P2, and provider edge 2 router. So yeah, let's open up provider edge 1. Here you can see we got the loopbacks on these routers right here. So loopback 0. This one's actually loopback 1. That's what threw me off last time. Yeah, so we got that right there. So we'll do a quick show IP interface brief. You see I got my IP addresses configured, loopback configured, right? Now show section OSPF. This is going to be my configurations for the OSPF underlay. I have router OSPF process ID 1, the network statements, 1 for the interfaces, physical interface, 1 for the loopback, and then you can see the configurations on that loopback I have is IP address 100.1, and then IP OSPF network point to point, right? So I did this for all 4 routers in the MPLS core, and if I do a show IP route OSPF, you can see that I am learning the loopbacks from all the other ones, right? So do a quick ping test. So now I have connectivity from provider edge 1 to provider edge 2, which is very important because if I want to establish, one MPLS connectivity, and then also the multi-protocol BGP with VPN 4, I need to have that connectivity. So yeah, that's all it takes for the OSPF underlay. You can use IS routing protocol, but I chose OSPF. So yeah, then task 2 is establish connectivity with the customer edge routers to the provider edge routers. So we're going to establish connectivity from here to here, and then vice versa, provider edge 2 to branch A router, right? So let's go ahead and get started here. We'll start with the HQ router. Okay. All right, so this is just a customer edge router. It's going to be very simple here. We're going to do show IP interface brief just to make sure our interfaces are configured. We've got that one configured. Ethernet 00 is the one we're looking at, and loopback 0 is going to be the one we're looking at. So ultimately, we're going to advertise 1.1.1.1, and we're going to want to see that on the branch A router. Okay. So we're going to do a router OSPF 100. Router ID 1.1.1.1. We're doing network statement of 77.55.10.0.3 into area 0. And we're going to also do to area 0. So that'll take care of those interfaces there. We want to place those in OSPF. Now we're going to come over to provider edge 1. And do the same thing here, but in order to establish connectivity, we're going to use VRFs, right? So on the provider edges, we're going to be running the VRFs. That way it can distinguish customers. So we're going to start off with creating a VRF, IPVRF HQ is what I'm going to name it. We're going to put a route distinguisher of 65,000 to 100. Because I'm using BGP autonomous system 65,000, and MPLS, I'm going to use that. And then I'm going to use 100 for being the router OSPF process that the HQ is going to use. So that's all I did there. Route target, we're going to keep that the same. And that's it. Once we create the VRF, we're going to assign it to an interface. So we're going to do interface gig 1, which is one facing the HQ router. We're going to do IP-VRF forwarding. If you have an IP address, it'll take it off. I don't at the moment, so now we can do IP-1, IP address. Oh, I did the wrong command, didn't I? Yep. Interface gig 1, no IP-VRF forwarding. You see that there? I did IP-VRF forwarding, and then it placed it into VRF configuration. Oh, interesting, huh? Interface gig 1, we do IP-VRF forwarding HQ. Almost threw me out. You see how I stay in interface configuration mode? Yep. So now we're going to apply the IP address 10.2. Shut it. Right, so right now we have the IP address configured. Right now we should ping using the VRF to 77.55.10.1. This will work. Now we won't be able to ping 1.1.1.1 yet. It's because we don't have the OSPF process configured on provider edge 1, right? So let's go ahead and do that. It has to be VRF mode, right? So we're going to do router OSPF 100 VRF. We're going to name this HQ. So once we do that, we are going to advertise the network that we have. You should see an OSPF adjacency come up. There we go. So now if I do a show IP route OSPF, oops, those are the underlay, show IP route VRF HQ, you should be able to see that we have 1.1.1.1 being shown there, ping VRF HQ 1.1.1. So that takes care of HQ router to PE1 connectivity. We're going to go ahead and speed through the provider edge 2 and branch A over here. So let's go ahead and do that. This is going to be branch A. So now we're going to do the same thing. OSPF 100 network. Oh, this one's going to be 2.2.2. That's going to be 0. 4. 0. That takes care of that. 2. Again, we're going to create the VRF first. Distinguisher, we're going to keep this the same as what we did on the other router. Target's going to be the same. We go into that interface. VRF forwarding HQ, then we can assign it its IP address. 10. What is that one going to be? 10.5. Now we're going to create the VRF, the OSPF process, VRF HQ. Here we're going to do the network statement. Network 77.55.10.4. Should see an adjacency come up if I did everything correctly. Yep, so there's the adjacency. We can do show IP route VRF HQ just to verify ping VRF HQ 2.2.2.2. So now that takes care of this requirement of established connectivity with the customer edge routers to the provider edge routers. So those are good. They can ping and talk to each other. Now we're going to task number 3 is configure MPLS on the MPLS core. Like I said before, the MPLS core is right here in purple. We've got provider edge, provider 1, provider 2. Now there's 2 ways to configure the MPLS on here. We can, if we're running OSPF, we can do it in router OSPF mode to configure all the interfaces that are running OSPF. But I like to do per interface, so we'll go ahead and do that. We'll start over here with provider edge 2. It's pretty simple. We're going to go to configure terminal, interface gig 1, and all we're going to type is MPLS IP. That will enable MPLS on that interface. So we'll go to provider 2. We're going to do the same thing for both of its interfaces. Now you notice that on provider edge 2, we only did gig 1, right? We're not supposed to do gig 2 or gig 3 because those are going to our customers. We want to do it only towards our MPLS core. So in provider 2, since it is in our MPLS core, that path has to go through gig 1 and gig 2. So we're going to do both. It's gig 1, MPLS IP. Now take notice on whenever I apply it to gig 2, it will go ahead and establish an LDP neighbor because that's the protocol that it's using. So that's good. We'll go verify that after we're all complete. Now we have P1 here. We'll do the same thing, interface gig 2, MPLS IP, interface gig 1, MPLS IP. You see the neighborship there. Last one is going to be PE1. T interface gig 2 MPLS IP. Should see neighborship come up. All right, so quick little show command. We got show MPLS LDP neighbor. That's going to show you your neighbor right there. Our peer is 192.168.100.2, which is the loopback, so that's good. It is up, has an uptime right there. That's good. So show MPLS forwarding table. Oh, forwarding table. Something that's just forwarding table. Yeah, this guy. So that's going to show you the local labels, the outgoing labels. So if you see, let's take a look here. Yeah, you can see how local label 18, pop label outgoing. Let's say 2 outgoing interfaces, next hop. Yeah, so you can see the labels there. So that takes care of our task of configuring MPLS and MPLS core. Pretty simple per interface. Now we're going to go get started with multi-protocol BGP, starting with the VPN4. So we're going to go ahead and start running BGP on provider edge 1 and provider edge 2. Provider 1 and provider 2 do not get BGP, only these provider edges. And we'll start with the VPN4 neighborship, so that way we can go a step at a time here. So let's open up provider edge 1. All right, so we're going to do router BGP 65000. Log neighbor changes. After that, we're going to do neighbor of 192.168.100.4. Remote autonomous system 65,000. This is going to be a IBGP neighborship, so we don't have to do BGP multi-hop. Now we're going to do same command, but we're going to do update source. It's going to be loopback 0 for this one. Now once that's complete, we go to address family address family VPN4 unicast. We do neighbor 192.168.100.4 activate neighbor send community extended. We're going to send those community attributes. So that's all you have to do on this side for the VPN4. We're going to go over to provider edge 2 and do the same thing over there. Router BGP 65,000. BGP log neighbor changes. Do neighbor of 192.168.100.1. Oops. Remote autonomous system 65,000. Now we're going to do an update source. Oh, we see a BGP neighborship already. We're going to see an update source. Update source of loopback 1 for this one, just because loopback 1 is the one that's configured. So there we have it. Now we're going to do address family VPN4 unicast. And we're going to do neighbor 192.168.100.1 activate. So there you can see it's down. It's reset and it's down and then it came back up. We'll do send community extended. So that'll take care of that configuration for the VPN4. And you can see here, show run section BGP. This is what we have currently. Router BGP 65,000. We established the neighborship first, update source, and then address family VPN4. Right. So if we do a show IP BGP all summary, it shows your neighbor there. It shows for what address family, right? You could also, to get a little bit more details, you could do show IP BGP VPN for all neighbors. That's going to show you your neighbors for VPN4. BGP state established and then uptime, right? So that's good. We've established that. I think show IP BGP VPN for all summary. Oh, I'm sorry. Show IP, not that command. Show IP BGP VPN4. Right. That command, show IP BGP VPN4 all, will show you the routes. We're just not learning any right now. We're not doing any redistribution. So yeah, we'll come back to that one later. So we've established the multi-protocol BGP starting with VPN4 from provider edge 1 to provider edge 2. So that's working. We have our neighborship there. Now, our ultimate goal is we want to, see the routes from HQ router all the way to branch A router. Right? So how do we do that? We have to, since this is running an OSPF routing protocol, and then here we have BGP with VPN4 protocol, we have to do some redistribution from OSPF into BGP. So we'll take a look at it in a path, right? So from here, HQ router to a branch A router. If we want to get 1.1.1.1 over to this, we have to redistribute from OSPF into BGP right here on provider edge 1. And then it's going to go through this path, blah, blah, blah. So then provider edge 2 is going to learn it via BGP. So we have to redistribute BGP into OSPF here, and then branch A router can see that route. And then we'll do vice versa. So let's get into it. Again, like I said, no bull. This is, straight CLI configuration. So let's take a look at what we have. We'll do a show run section BGP. This is what we have now. The show run section OSPF. Right, that's what we have now. So we're going to go ahead and create our router BGP address family for VRF. We're going to do configure terminal router BGP 65,000 address family IPv4 VRF HQ. So once we create that, we're kind of enabling the VRF HQ, right? We don't have to put any network statements because we're not going to, put any network statements in BGP at all. So, but here, I want to redistribute OSPF process ID 100. Now this is the one that we created locally on the router as well. VRF HQ. Okay, so we are redistributing. Sometimes it can get confusing, but since we are in BGP address family, we are redistributing OSPF process ID 100 VRF HQ into BGP. Okay, so we're doing that. Now we're going to go ahead and do the vice versa. So we'll go into router OSPF 100 VRF HQ, and here we're going to redistribute BGP 65,000 subnets. Now on provider edge 2, I ran that same command, right? And you can see now that we are learning 1.1.1.1, next hop being this loopback interface is on provider edge 1. So our traffic flow is this HQ router is passing its loopback interface through provider edge 1 now, P1, P2, and it's going to be PE2 only to the BGP side, right? It is not going over here yet because we haven't configured redistribution on provider edge 2. So provider edge 1 is taken care of. So let's go ahead and work on provider edge 2. So we are going to do the same thing on, if I could type router BGP 65,000, address family IPv4, VRF, HQ. We're going to redistribute OSPF 100 VRF HQ into BGP. So that takes care of that redistribution. And then we are going to take care of the OSPF as well. Router, OSPF 100 VRF HQ. So this one right here will allow HQ routers networks to be over here to branch A router. So router OSPF 100, we're going to redistribute BGP 65,000 subnets. Right, that should take care of that. So let's see if it worked. Let's log into branch A router and see if we can see what we need to see. So this is our router here, and I'm going to bring up actually HQ router as well. So these are respective routers for each site. This one's here, this one's here. HQ router is advertising 1.1.1.1. Branch A router is advertising 2.2.2.2. So we're going to do a quick show IP route. Lo and behold, we can see an OSPF intra-area route from 1.1.1.1, ES7710.5, which is here. So now I'm connected to our branch A, to our HQ, and you should be able to ping it. And there you go. And vice versa, you should do a show IP route OSPF. You see the 2.2.2 and then the 10.4 network as well. So yeah, that's how you configure multi-protocol BGP and MPLS. Now, you would do the same exact thing to connect a different, another customer. So, this, you can, copy this and do the same thing. The only thing is you just got a different interface, you create a different VRF, and then a different OSPF VRF process, right? So this is what, providers do. It's kind of daunting when you don't know and understand what you're doing, but, you just take the time to learn it. It's not difficult. Obviously it takes practice, but yeah, and, this is one difference that I'd like to know, that this is not VRF Lite. This is, VRF, right? Virtual routing forwarding. not light, because we are using MPLS and multi-protocol BGP. So, but yeah, if you know this was informative, or there's any questions, put something in the comments, and I'll look at it. Again, this is no bull, straight to the point. So, thanks for watching.